I handed out notes. Today's going to go by really, really quick. In my opinion, this is an easy concept to understand, but there is a tad bit of math involved. Okay? And all it is addition and subtraction. There's no multiplying. There's no dividing. You do have to know your kinetic and potential energy pretty well, which I feel like at this point we do. So let's see how today is going to roll. All right? The whole point of today is calculating mechanical energy. Okay? And we will see on this point, I don't think there's anything you have to fill in right here. Total mechanical energy is both energy of motion, which is kinetic, and energy of position, which we know is potential energy. Okay, so that's going to be both of those. In a frictionless system, energy is converted back and forth. So that goes back to when I showed that roller coaster video of potential and kinetic energy kind of being fluid with each other. One goes up, the other goes down, back and forth. You can have, sometimes you can have both of them at the same time. We're going to calculate that today, okay? You can add kinetic plus potential at each stage to track the energy. Total mechanical energy, the sum of kinetic and potential at each point of movement. Okay, now let's talk about how this is going to play with what we did yesterday. What did we talk about yesterday? Does anybody remember? How energy changes from one form to another. Okay, at the very top of our page, there was a law. What was that law from yesterday? Energy is always, starts with a C, conserved, the conservation of energy. Okay, and what we said at that point is that energy cannot be created or destroyed. All right, so how that plays with today is our total mechanical energy, kinetic plus potential. The total should always be the same no matter what stage you're at in your situation. Okay, so let's see exactly what that looks like. This is our example one. This is where you're going to start writing in the blanks here. Okay, we're going to talk about what goes where. All right, so this first stage here, our total mechanical energy is 90,000. All right, so this is how much energy we have in this system. That 90,000 should be the same everywhere, because energy cannot be created or destroyed. All right, now, total mechanical energy is kinetic plus potential. So if we have potential energy, how do I find kinetic energy?
You have to subtract those two.
Yes, because we want these two to equal 90,000. All right, so you don't have to write this down if you don't want to. It's just kind of a mental note. 90,000 minus 75,000 to get kinetic energy, which would be 15,000 joules. I do want you to fill in that blank right there, 15,000 joules. Okay, so in everything that we do, our kinetic plus potential should equal total mechanical energy. Okay, so 75 plus 15,000 should equal 90,000. All right? Now, can anybody tell me what the total mechanical energy is in this phase of our roller coaster?
90,000.
It's still going to be 90,000, okay? Our total mechanical energy, you don't have to write this down. It's just another note that I wanted to talk about. TME must be the same throughout the entire system. Only potential and kinetic energy will change. And that goes back to the law of conservation of energy, okay? However much energy we start with, we should also end up with, okay? So I know that my total mechanical energy is going to be 90,000. How would I find kinetic energy? I would subtract, so 90,000 minus 45,000 gives me a kinetic energy of 45,000 joules. You can always double check by adding your KE and PE, and it should equal your TME, total mechanical energy. Is this making sense to you guys? Okay, all you got to remember is KE plus PE equals TME, total mechanical energy. All right, let's move on to this next phase right here. There's my little mental math note. What's going to be my total mechanical energy at this point? 90,000. TME should never change. Got it? TME is going to be the same throughout the entire system. And what would I do to find PE in this case?
Still subtract.
Okay, we're always going to be subtracting, right? So now I'm going to do 90,000 minus 35,000, and that's going to get me a potential energy of 55,000 joules. So that's the potential energy there. All right, right here, we're at the bottom of our loop. So this is going to be where we have the most kinetic energy and 0 potential energy, because we're at that bottom. If you imagine it going, okay, at the bottom of a loop is when we have the most kinetic. But let's go ahead and start. What's my TME?
90,000.
90,000 joules. If potential is 0, what's my kinetic?
90.
90,000 joules. Okay? Everything has to equal up to TME. Does this make sense to you guys? Okay, and it's all about conserving energy. So at the top of this coaster, we had a total of 90,000 joules. At the bottom of this coaster, we're still looking at 90,000 joules. Okay, let's go ahead and flip to that next example at the bottom of your page, and then we're going to be done as far as notes go. My total mechanical energy starts at 5,100 joules. So what can you automatically assume about TMEs here?
They're going to be 5,100.
They're going to be the same. So I'm going to go ahead and fill that in. Okay? So my total mechanical energy should match at all 3 points. So I went ahead and filled that information in first this go around. Now, let's start filling in our kinetic energies and potential energies. Levi, don't answer. How do I get the kinetic energy on this phase of our pendulum? Yep, I'm going to do 5,100 minus 4,500, okay? And that's going to give me 600 joules. So my kinetic energy at this point is 600. My potential energy is 4,500. Total energy is 5,100. Okay, this one over here should be pretty simple. If I have potential energy at 0, then what's my kinetic energy? 5,100, yes. Okay? So that one would look like that. Okay? Somebody tell me, how am I going to figure out potential energy up here? Yep, more subtraction. Okay? 5,100 minus 600 gives me potential energy of 4,500 joules. Do you think we can handle total mechanical energy? I think so too. Now what I want to do is I'm going to show you what your assignment looks like on Canvas. That way, because it's kind of different, I want to make sure y'all understand how to answer it. So our assignment today is going to be 9.6 assignment, calculating mechanical energy. And it says, choose the amount of energy that should go for each letter in each problem. You may use 9.6 notes to help you. You get 3 attempts, all of that fun stuff. So this is how I created this one. First of all, this little calculator up there, you can click on it and it's a calculator if you don't have a phone or anything like that. Okay, I put it into today's assignment so that you can use it there. Okay, so this picture goes with these. So if I think A equals 515, I would put 515 there. Does that make sense? Now, B is in 2 spots. Okay, do y'all see that? What is B in this case? What would my answer be? 515, because that's what I started off with. So both of my other total mechanical energy should be that. Make sure you pick 515 mechanical energy. Does that make sense? Okay, if you pick 515 kinetic energy, it's not going to be right, and you're going to get really frustrated. Okay, so make sure you're paying attention to what energy you're calculating. So B should be mechanical energy because it's talking about these right here. Does that make sense? Okay, do y'all have any questions? All right, go ahead and knock this assignment out. Make sure you took care of yesterday's assignment, and y'all are good to go after that.